Cord. Need these. 1-5, day 1. Where are the functions positive and negative? So we want to look at all of the quadrants and see which function should be positive and negative in each of the quadrants. So, and remember, we find all of our 6 ratios off of an ordered pair. So all we care about is whether the ordered pair is positive or negative. So in the first quadrant, because all of our points are positive, positive, and the R is always positive, when I set up ratios and I flip them over, what can you tell me about all 6 trig functions in quadrant 1? They're all positive. Now we'll go over to quadrant 2. What are the ordered pairs in quadrant 2? What's the all x values in quadrant 2 are, Adam? And then all of the y values are positive. Because you're going left for the negative, up for the positive, and then the R is always positive. So let's look at sine and cosecant. What am I making my ratio out of here with sine? Which 2 is it again? Sine goes with y. So it's y over r, positive over positive. Positive. Now let's go with cosine and its reciprocal secant. Cosine's attached to the x, so negative over positive. When you divide, what do you get? Negative. And when you flip it over, positive over negative, still negative. And then tangent and cotangent. Tangent is the y divided by the x. So I've got positive divided by negative. It's going to come out negative. So you've got sine and cosecant that are positive. The other 4 are negative. So we're going to focus on the positive ones because there's going to be less of them. So here they're all positive. Here only sine and its reciprocal are positive. Let's go down to quadrant 3. What are all of our ordered pairs in quadrant 3? Adam? Negative, negative. And what's the R value? Always positive. So we'll go through them again. Sine and cosecant. Sine's attached to y. Get your brain wrapped around that. So I've got a negative divided by a positive. Sine is now negative. Cosine and secant, that's our x over r. That's negative divided by positive. That's going to come up negative. And then tangent and cotangent, what are we going to have there? Positive, because it's the y divided by the x. Negative divided by negative will come out positive. So here's our positive one here. And then our last quadrant, what are our ordered pairs here? Positive, negative. So to the right's positive, down's negative, and we'll run through them again. Oh, R is always positive. So we got sine and cosecant. Again, sine's attached to y. Negative over positive. Cosine and secant. Positive over positive. And then tangent and cotangent. We've got our negative over our positive. Okay, I always think of, sine and cosine. If I'm thinking cosine, I know it's attached to x, so I know x is positive, x-axis, think positive this way, so I know cosine is going to be positive in the two quadrants that are to the right, because that's where x is positive. Cosine being attached to x, when the x-axis is negative, I know cosine's negative in these two. Then I think sine. Sine's the y. Well, y-axis is positive up, so that means sine is positive up. So sine's positive in these two. Y is negative here, so sine is negative in these two. Tangent, I've got to actually think about the ordered pair and see what I've got. So that's the way I like to wrap my brain around that. Other than looking back at this and saying, oh, you can just kind of think about them in your head a little quicker. All right, so think in your head. Don't look at this. Try not to look at this. Think in your head. Identify the quadrant. I mean, if you have to look at that, but try to think in your head. So where am I if the sine, let me write that again. The sine of an angle theta is greater than 0, and the cosine of that same angle theta is less than 0. So, again, try not to look up at that chart we just made. Think sine being the y value. Where is y positive? Because greater than 0 is positive. So think y-axis. Which quadrants have the y-axis positive? What are my two options here, Adam? First and second. So theta is either in 1 or 2, because that's where the y is positive. Now cosine. Cosine's attached to x. So where is the x-axis less than 0 at? Which two quadrants? 2 or 3? So where are the two things happening at? Quadrant 2. So you don't have to look at that table. You can think about it and get it and solidify that in your brain. Let me try another one of these, part B. Tangent less than 0 and sine of the same angle, I gotta have an angle, less than 0. Tangent's the tougher one because you gotta look at the whole ordered pair. So let's start with sine and limit the two quadrants we're gonna look at. Where is sine less than 0 at? Sine's the y-axis. 3 or 4. So we know we're limited down to those two. Can't be in 1 or 2. So now think, remember tangent's the two, the y and the x, because they're divided. What are my ordered pairs in quadrant 3? What are they in terms of positives and negative? Negative, negative. And I know I've got to divide those. What happens when I divide a negative by a negative? Positive. Well, I don't want positive. I want less than 0. So it's got to be 4. But that's because it's positive to the right and then negative down. So it's going to be quadrant 4. So could you figure this out just by looking back at this chart that we did? Yes, but that's not what I want you to have to rely on the chart. I want you to be able to think about it. Oh, identities. Yay. Well, let's see what goodness we have. Oh, nice. Identities today. Okay. Reciprocal identities. You already know these. Reciprocal identities. Little fact families. We know that if we flip sine over What ratio are we creating again? Which trig functions attached to sines? Cosecant. So, cosecant, oops, not cosine. Cosecant is equal to sine flipped over. How do I show sine flipped over? 1 over sine. Well, what if I knew the cosecant ratio? How do I get the sine ratio back? Flip that over. So sine is equal to cosecant flipped over. So think about a 1 underneath it. 1 over cosecant. What happens if I take the sine ratio and multiply it by the cosecant ratio? Let me do a little example. If sine ratio was, say, -1/2, what's the reciprocal of -1/2? -2. What's going to happen every time you multiply a number by its reciprocal? You're going to get 1. So with the sine ratio multiplied by the cosecant ratio, always going to be 1. There's our first fact family. How do we get the secant ratio? Which function are we flipping over? 1 over cosine. And if I had secant given to me, I could get cosine by flipping that over. And I know if I multiply the cosine ratio by the secant ratio, because those are reciprocals of each other, everything reduces down to 1. And our last one is the tangent-cotangent family. Cotangent is tangent flipped over. Tangent is cotangent flipped over. And the tangent ratio multiplied by the cotangent ratio will give us 1. So if I give you the tangent ratio, can you tell me the cotangent ratio? Hopefully you answer yes, because the tangent and cotangent are reciprocal functions. All you've got to do is flip this over. So cotangent would equal, fill in the blank here, -1/5 flipped over, -5. All right, easy enough. We've been doing that. What if I give you 3.2 for the cosecant, and I ask you for sine? Well, how are cosecant and sine related? They're reciprocals. How do I flip this number over? 1 over 3.2. Think about a 1 underneath it. So I'm going to go 1 over 3.2. But how many times in your life do you see decimals inside of fractions? Not often do we leave that ugliness. If it starts as a decimal, finish as a decimal. All you got to do is pick up your calculator. What's 1 divided by 3.2? So the process is flip it over, but we don't want to leave something that ugly because you're not going to see that as an answer. Anybody have that? 0.31 about? Good enough. So if you start as a fraction, you can finish as a whole number or fraction. If you start as a decimal, finish as a decimal. Okay. Very easy. Usually there's no problems realizing that, okay, these are just reciprocal functions. It's just got to flip over to get the other one. Here's where some confusion comes in. Do I have this one here? Solve for theta. And here's what I know. The tangent of 3 theta minus 4 is equal to 1 over the cotangent of 5 theta minus 8. Right now my thetas are sitting in the angle spots here, but what I want you to notice is we've got a function here, 1 over cotangent. This is cotangent flipped over. What's another way to write 1 over cotangent? One over cotangent that is tangent. He's got a little Halloween costume on already. It's tangent hiding on us. Oh, I got nothing. Tangent. It's got a Halloween costume on. Can you see him? There's a little smile, thanks. 1 over cotangent is tangent, hiding. Take his costume off. Oh look, it's tangent. So now I've got an equation that says the tangent of something equals the tangent of something. Well, if 2 tangent ratios are going to be equal, what has to happen with these things under my fingers? Do you agree that those angles would have to be the same angle in order to have the same tangent ratio? So really, we can just ignore this. I don't care. I know that these 2 angles have to equal each other now. So 3 theta minus 4 has to equal 5 theta minus 8. And now it's just some simple algebra to solve for theta. Okay, one more set of identities. These are our Pythagorean identities. Obviously going to be using Pythagorean theorem. X, Y, and R there's going to be 3 Pythagorean identities because we start with Pythagorean theorem. So according to this triangle, the way we have it labeled, leg squared plus leg squared is going to equal hypotenuse squared. So we start with x squared plus y squared equals r squared. Now we want to make ratios out of this, fractions. So I'm going to choose to go through first and divide both sides of this equation by r squared. So I'm going to divide the right side by r squared, divide this by r squared, and I'm going to divide this by r squared. Legal algebra move. Well, I can see on the right, r squared divided by r squared is going to give me 1. Now, using our exponent rules from algebra, when you've got 2 things squared, it's legal to say that's equal to the fraction squared. So I took the x squared over r squared and made it x over r, the fraction squared. Plus, this could be rewritten y over r squared. So now tell me, which trig function is x over r? That's cosine. So this is cosine squared of angle theta. What is y over r? Sine squared. So what this does for me is, if I know cosine, I can now find sine. Or if I know sine, I can now find cosine. So now I've got a relationship that's going to let me, given one of these, find the other one. It's a good thing. Okay? So we created the first Pythagorean identity by taking Pythagorean theorem and dividing through by r squared. Well, let's go back. Start with Pythagorean theorem again. Now we can go through and divide everything by, let's go divide through by x squared. See what identity we come up with. So first is x squared divided by x squared. That simplifies to 1. Now we'll break this apart into y over x squared. That's one of our trig functions. And then this one becomes r over x squared. So let's see what we got here. 1 plus, which trig function, Adam? That's tangent. Which one is r over x? Well, think x over r. Which one's x over r? Cosine. Cosine flipped over is secant. So now we've got a function knowing tangent, we can find secant. If I've got secant, I can flip it over and get cosine. Or if I had tangent, I can flip it over and get cotangent. Now we're relating some other functions together other than just flipping. And then our last Pythagorean identity. What's left to divide through by? The y squared. So we'll divide through by y squared. Break that into x over y squared. 1 r over y squared. So now, which function is x over y? Cotangent. So we've got cotangent squared. Plus 1. And which one is r over y? I got to think y over r is sine, cosecant. Okay. Now if I know one of these, I can find the other one. Okay, last problem. Can I get rid of this? Use identities. We will spend another day on this because it gets a little confusing. To find the sign of beta, just like a theta, only another Greek letter, if the cosine of beta equals -1/4 and beta is in quadrant 2. So we've got two kinds of identities, reciprocals, and now we've got those three Pythagorean identities. So, is there an identity that ties together sine and cosine? Definitely not reciprocal, so it's got to be the Pythagorean. Which one is it, Adam?
It's like the cosine squared of theta plus the sine squared of theta equals 1.
Yep, it's our first Pythagorean identity here. Cosine squared plus sine squared is always going to equal 1. So we'll start with that one. Cosine squared plus sine squared equals 1. We know the cosine ratio. It gave it to you as negative 1/4. So we're going to substitute in, plug and chug. So cosine's negative 1/4. The identity says we've got to square that number. Okay, squaring a fraction just means square the numerator, square the denominator. So negative 1 squared is positive 1, and 4 squared is, so we get 1/16. We're going to solve for this, so we're going to subtract 1/16. So sine squared. Okay, we need a common denominator to add and subtract fractions. What's my common denominator if I've got 1 over 1 and I'm going to subtract 1 over 16? What are you going to change the 1 over 1 into? 16 over 16. So 16 minus 1 is going to give us 15/16. What do I have to do now? My goal was to find sine of beta. I've got sine squared of beta. Square root both sides. When you introduce a square root, what do you have to remember? Plus or minus. We got to decide whether our sine ratio is going to be positive or negative. We'll do that on the next line. So when we take the square root of a fraction, you got to see it as the square root of the top and the square root of the bottom. So I've got square root of 15 over square root of 16. Well, nice that this one came out because the square root of 16 is going to simplify to a 4, and we're going to keep the square root of 15. Now that positive or negative, we got to still think about that. Go back to the original information. What piece of information up there did I give you that's going to help us decide whether we should be positive or negative? Lexi? Quadrant 2. Yeah. So the quadrant anyway. Okay, if the angle's in 2, think about quadrant 2. We're trying to find sine. Sine is attached to what part of the ordered pair?
Y.
The y. The y in quadrant 2 is?
Positive.
Positive. So we're going to keep positive. Can do these? Yay? I don't think we're going to do a B. Or do I? Oh, there it is. I lied. There's B. Can you find the tangent of theta if cosine equals 1/3 and theta is in quadrant 4? Okay. Is there an identity that ties together tangent with cosine? Adam. It's our third one. Let me find my paper. Are you sure?
Oh, wait. No.
It's not. Okay. Well, I see tangent with secant. Oh. Yeah, if they give me cosine, what other ratio do we know automatically? Secant, because of the reciprocal thing. Very easy. So, giving us one ratio, we automatically get a second one by flipping it over. So you had to come up with that. Now take a look. Our second Pythagorean has tangent and secant. So we're going to use this one. So we'll start with 1 plus tan squared equals secant squared. And again, it's plug and chug. So we keep the 1 plus tan squared. We know secant 3, and we've got to square it. We'll subtract 1. So 3 squared minus 1 leaves us with 8. That's our tan squared. I want tan. And when you do the square root, don't forget to think, is it positive or negative? We'll look at the quadrant to decide. Okay, let's pick out the positive or negative right now. Quadrant 4. In quadrant 4, our ordered pairs are right is positive, down is negative. That's how I get into quadrant 4, right and down. So is tangent going to be positive or negative in quadrant 4? Adam?
Negative.
Because it's y divided by x. So we need the negative. Square root of 8, what are you going to do with that, Adam?
You're going to make it 2 square root of 2.
2 square root of 2, because that's 4 times 2. Square root of 4 is a 2. Square root of 2. Yay. Page 51.